Hello everyone, this is Miss Crute, and today we're going to be working on graphing direct and inverse variation. So as a reminder, if we're talking about direct variation, the equation is y equals k times x. And remember, k is just a number, it could be any number. If we're talking about inverse variation, we're talking about y equals k over x. And again, k is just a number. So when we're graphing, just like we would with any other type of graphing, you always are going to start by solving for y. So if we look at example 1, that's already solved for y, so we can move on to step number 2. Then we need to identify if it is direct or inverse variation. So we want to compare it to the original equations up here. We've got y equals 3x. So that's like y equals a number times x, so that would be direct variation. Now, once you have decided whether it's direct or inverse, you want to go on to step 3 and make an xy table. So you need to put at least 3 points in to get your table. 5 is better though. So we're going to use -2, -1, 0, 1, and 2. These are always good choices for when you have direct variation. So if I plug in -2, 3 times -2 is -6. 3 times -1 is -3. 0 times 3x is 0. 3 times 1 is 3. 3 times 2 is 6. So now we can plot those points. I've got -2, -6, -1, -3, 0, 0, 1, 3, and 2, 6. And then we can draw a straight line to connect those dots. So now we can go over to example 2. We have xy equals 6. So first step is to solve for y. So in order to get y by itself, we need to divide both sides by x. So we get y equals 6 over x. Now to identify the type, we compare it to the original types, and that would be inverse variation because we have a number over x. Now we can go ahead and make our xy table. Now in this case, we don't necessarily just want to choose the numbers from -2 to 2 because we want to choose numbers that can divide the number on top. So we want to pick numbers that will divide 6. So in this case, those numbers will work, but for example, if you had 7, you wouldn't want to pick -2 because 7 divided by -2 is a fraction, not a whole number. So you always want to try and pick numbers that will give you a whole number answer. So I'm going to do -2, -1, 0, 1, and 2. 6 divided by -2 is -3. 6 divided by -1 is -6. 6 divided by 0, does that work? No, we can't do 6 over 0, so we don't want to choose that as one of our numbers. Let's see if with just doing these 4 we'll be able to figure out the graph. Then we do 6 divided by 1 is 6, and 6 divided by 2 is 3. So I've got -2, -3, -1, -6. We've got 1, 6, and 2, 3. Now looking at these dots, this doesn't really look like a straight line, and that's because it isn't. Inverse variation, the graphs aren't straight lines. The graphs form a curve like this. The reason it forms those two curves is because we can't have an x value of 0 because we just talked about you can't divide by 0. 6 over 0 is undefined. So the line will never cross the y-axis. And then y will never be 0 because there's no number you can divide 6 by that equals 0. So that means that the line can never touch the x-axis, which is why we get these two curves here. Alright, so now that we know how to graph, we also want to be able to write the equation of a graph that's given to us. When you do this, first you need to identify the type of variation you have. So here, if we compare it to the graphs that we just did, this would be an example of inverse variation. Now we want to find a point on the graph. When you're looking for a point on the graph, you're looking for a point that goes exactly through the corners of a box. So looking around here, I see that this is a point. That's 2, -3. In order to write the formula for this inverse variation, we need to start with the equation. So that's y equals k over x. Now, we know the point 2, -3 is on this graph, so we can plug that in to find k. So -3 equals k over 2. In order to solve for k, I can multiply by 2 on each side. So we get -6 equals k. So that tells us that the equation is y equals -6 over, oops, not k, that should be an x, sorry about that. And there's our equation. Looking at number 2, first we want to identify the type, and this would be direct. Now we want to use the same technique we just did to find the equation, but since it's direct, we're going to start with y equals kx. Now we need to find a point. It'll always be tempting to use the point 0, 0, but that one will never help you find k because every direct variation graph goes through the point 0, 0. So you need to find a point different than 0, 0. So I see right here this point, which is 1, 2. So we can plug that in, and I've got 2 equals k times 1. So really, that just ends up being 2 equals k, because 1 times k is the same thing as k. So that means our equation is y equals 2x. Alright, so that's all I've got for you for notes. You have an example of each type of problem that'll be on your in-class practice, so go ahead over to a table and get to work on the in-class practice. Good luck!